Dr. Baker, and what I wanted to do was touch base with the class this morning. Last week, we tried to do a online Blackboard Collaborate session. I think I have resolved the issues with being able to screen share, but wanted to just make this quick video since I meant to post it yesterday and I'm a little late in getting it posted. Once again, my goal here is to make sure everybody's on track and we understand where we are in the course. So I will discuss briefly last week. So I have not graded the exams yet. I hope to do that today. I did, however, grade the projects. Most people got 100 points on the projects. I got very nice reports from the vast majority of the class. There were a couple of students who submitted not a report. It looked like a table with some results, may or may not have had a circuit schematic, was missing or missing most of a multi-sim simulation. So you actually got very little credit for that because I was very clear in the assignment that this did require a report. And just to give you some ways to calibrate, most of the submissions that I received contained extensive extensive data output from multisim, as well as a full listing within a text and description of all equations that were used in the model, a full listing of all of the results from the hand calculations, usually summarized in a table with comparison results from the multisim, and then a discussion of what happened and the simulation of when the load becomes unbalanced, which, as you know, was done only on multisim due to the fact that hand calculations for unbalanced loads are very complicated. So just to calibrate kind of what was an A on that project is most students' reports averaged between 10 and 15 pages in length. Some were shorter and actually did a good job of being concise and didn't lose any credit for a short report, as long as it was a formal report, well written, and all the information was there. So some people, they made smaller tables, smaller graphs, etc. So that was good, and So most reports averaged, as I said, between 10 and 15 pages. I did have some reports that were up to almost 30 pages. So if you're one of the people who turned in a page and a half of numbers and you got a 25, that's fine. So that's what you have to compare your report to, and that was the expectation: a thorough and well-written report. Not necessarily a 30-page report, but I think I would find it very hard to document, turn in, write up, summarize, conclude in less than 8 pages, really. And the people I'm referring to turned in 1 or 2 pages. So that's where we are on that. And like I said, you should expect to see your exam grades completed probably tonight. I have intentionally asked the system not to report the grades automatically because it does make so many errors. For example, if the answer was 20.2 and you put 20.25, then the system will count it wrong and people freak out and start emailing me. So I just don't show the grades until I have personally gone in and graded your exams. And also that gives me an opportunity to look at your submitted handwritten work. All right, so let's talk about where we are now. We are now in Unit 2, Special Functions. And let me just real quick put my computer on Do Not Disturb so that you don't see all of my notifications pop up. So right now we are on Unit 2, Part 1, Special Functions and Laplace. Now I'm aware that many of you have had a course in linear systems where you covered the Laplace transform, so this first part of Unit 2 may be mostly a review for you. It's organized in a similar way to the last unit. There is a section on class videos and PowerPoint slides. Lots of these here. We start with special functions, where we talk about the step function and the impulse function. Then we discuss the Laplace transform definition and show you the tables. And then at that point on video 5, we talk about the initial and final value theorem and the inverse transform. Then a pretty extensive lecture on if you have a function given in the Laplace domain, what are the partial fraction techniques. Another follow-up video on initial and final value theorem, inverse Laplace transform examples, including some MATLAB examples. This is a special recording from last semester where I did more of a live video, and I think this is the same. And then here are some inverse transform worked examples, where I worked examples of taking the inverse transform, and I believe I did this on a tablet, so it would be similar to a Blackboard lecture. And then you have some PowerPoints and notes. So that's all. Basically, this is the chapter in your textbook, and I don't have your book in front of me, so I don't remember the chapter. I think it's 13, but it's the chapter on the Laplace transform, right up until the point where we do circuits applications. So most of that chapter is included in the material in the lectures. I believe there's some information on time domain and convolution that is not included as a part of this class. So you're only responsible for Laplace transform, inverse transform, initial and final value theorem, and the other things that are covered in this lecture. Once again, it is assumed that you have had probably 2 courses, both linear systems and a course in differential equations, where you have already covered this material, so it is should be mostly a review for you. So there is some homework. There are actually 2 homework sets. Let me go back to the main folder because I think they may be there. Plus notes. Homework 1, Laplace transforms, is the homework that I want you to look at on Laplace transforms. I do give you some specific problems to look at. Those are selected intentionally. So I would certainly recommend that at a very minimum, you work the problems that I have recommended. I did post some answers. They're not to all the problems, but they are to most of the problems. And then we do have a set homework 2 on the inverse transform. So to keep on track, you should definitely, by about Thursday of this week, Thursday or Friday, you should have worked through most of the materials in Unit 1. Now then, let's look at in Unit 2, Part 1. Now let's look at Part 2. Part 2 has more advanced materials, and as you will see, there is a lot here, which is why really you need to be by now probably halfway through Part 1 of Unit 2, because Part 2 is considerably lengthier. So here what we discuss is, and this was included in the previous section, so don't worry about that. Here we discuss how we apply the Laplace transform in circuits. So there are going to be several examples of how to solve circuits in the Laplace domain. And then there's quite a bit on RLC circuits, because in our course sequence, we do not cover RLC in circuits 1. It's covered in circuits 2. So there's going to be some discussion of RLC circuits, and there are multiple videos on that. One of these is a little more theoretical. I think the other is done on a tablet and is going to be a little more informal, but perhaps more helpful. Finally, there is the subject matter concludes with transfer functions and then some basic filtering. So lots of videos on filters. In this unit, we will cover through the low pass, passive, low pass and high pass, passive RL and RC. So the material in Unit 2 is broader. There's no project associated with Unit 2. So the second project actually occurs with material in Unit 3. That, however, let me say, material from Unit 2 is used in the project for Unit 3. It's just, it becomes more advanced what we're actually going to do. So I will go ahead and let you get started on the project, and it's done not in Multisim, it's actually done in MATLAB. So if you can do it in Multisim, and I typically put that on there as an extra credit option, but it is primarily done in MATLAB. So extremely important for you to watch the videos that demonstrate, and they're mixed in here among, especially from part 1. There are some videos on how to do transforms, inverse transforms, etc. in on MATLAB. This material we need to have wrapped up. Let me see if I can find a course calendar. I think by like a week from, really you should have everything done by a week from Wednesday. So a week from tomorrow. Remember, summer school moves extremely fast. Summer school moves extremely fast. I would say next Thursday at the latest, you need to be through all of this material. That's really close to 2 full weeks. So it's doable. Remember, these videos are short. They're 10 or 15 minutes. So watching 4 to 6 videos is the equivalent of attending 1 Tuesday, Thursday lecture. So before you get overwhelmed at the number of videos, remember they are broken up into short segments. So this is actually not any more time in watching videos than you would spend in sitting through a class if you were sitting through a class. But then remember, summer is greatly accelerated. So you basically have 3 times the intensity of work in a summer session that you would have in a regular semester. So you can expect to watch an hour and a half or more of videos every day in order to stay on track, especially with this next set of work. So that is where we are, and like I said, your goal should be to be completed with all of this by next Wednesday. I will hold a special session on Monday of next week where I address any questions. If you haven't attempted the homework, then you obviously don't know if you have any questions. So really important, if you do attend that session on Monday, that you have worked some problems, know what your questions are. On this section, I don't think I have posted any homework on circuit. Yeah, here we go. Suggested homework, circuits and Laplace, and then here are some solutions. And once again, I solved most of the problems. I do not always solve them to the final numerical answer. So I set them up, I get the equations, and then a lot of times the plugging into the calculator is left to you. That's for the purposes of time. That's what actually takes the time in a live lecture, is to push buttons into a calculator. So I do leave that for you, but I do show you how that is set up. Okay, so that is Unit 2. And it should be complete. I'm going to triple check just to be sure. Here's the transfer function and passive filter homework. I need to check this homework. I want to be sure that I have a MATLAB component, because there is some MATLAB work that you probably should do as a part of this unit. All right, so that's Unit 2. And just to go ahead, since we're giving an overview of the rest of the semester, the last part of the course is Unit 3. Unit 3, we will continue a discussion a little bit on active filters, which is filters with an op-amp. And then we have a unit on Bode plots. You also probably did Bode plots in linear systems. You should have. Anyone who's had a linear systems course should have done a Bode plot. If you have not, this will be new. plan to spend some time here if you have never done this before. And even if you have, we add a few twists. We add a MATLAB component of plotting Bode plots. Knowing how to plot Bode plots is essential for the final project and discussion, which will be on advanced filters. So the final project is basically to compare a couple of different kinds of higher order filters, primarily utilizing MATLAB and hand design calculations. So you'll design 2 different filters based on specifications I give you, and then you'll simulate those on MATLAB to get the output Bode plots. You'll compare the 2, you'll make some adjustments. So that's what is coming for the remainder of the course. I need to check back and look at my emails. I think I emailed out a schedule of when exam 2 and 3 would be. So if you received such an email or didn't receive such an email, I'd love to have feedback on that. I thought I sent that out, but when I looked at my sent mail this morning, excuse me, I could not find it. So if you did receive an email, it could be it got stuck in my draft folder and got inadvertently deleted. So if you have time today to check for that and just send me a quick email heads up that you do or do not have it, I would appreciate that. I need to get my calendar back out and check dates, but I know the exam is sometime next week. I was thinking it was on Thursday of next week, but I'm not 100% sure. So if you would give me a little bit of a response on that, I would appreciate it. So that is where we are. So Unit 2, need to be halfway through that Part 1 by probably Wednesday afternoon, Thursday morning, so that you don't fall behind. Okay, so I'm going to sign off here, and I will be available most of the week. I do intend to travel a little, so there may be a day where I'm out for the day because of kind of driving and no internet, but you still should expect, if you need anything, a response from me by the end of the day. The last day to drop in Summer 1 is, I want to say, June 25th. I'll have those exams graded. Double check that on the calendar just to be sure that that's the correct date. But I'll have those exams graded. Remember, there are only 5 grades this semester, 3 exam grades and 2 project grades. That first project, you'll need to look at the syllabus to see exactly how much it counts. I want to say, I just don't remember. It's either 10 or 15% of the grade. So that kind of gives you an idea where you stand. There is no makeup on that first project. You had plenty of time to do it, and the instructions were really pretty clear. And most people who, as I said, made an honest attempt, wrote a decent report, submitted all of their data and put appropriate equations and so on. Most people did get 100 on that first project. All right, so you have a good rest of the week, and contact me if you need anything. Thank you.